Good afternoon students. So in the last class we have completed integration by partial fractions, and in our earlier classes we have also completed integration by substitution. So this is the third method of integration, that is integration by parts. So this method is helpful in finding the integral of product of two functions. For example, if the function is like this, x into cos x. So to integrate these functions, product of these two functions, we have to make use of by parts concept, or else if we have this one, x square into log x, or x into e power x, in all these cases we have to go for integration by parts. So for this we have the standard formula. So let us write the formula for integration by parts. It is integral f of x into g of x dx, which is equals to, so f of x into integral of g of x dx minus integral, here we have to take the square bracket f dash of x, or the derivative of the first function f dash of x into integral of g of x dx, So here we have opened the bracket, here we have to close the bracket. So I am closing the bracket, and we have one more integral sign here. For this we have to write dx at the end. See here, this dx is for this particular integral, and this outer dx or the main dx is for this integral. So this is the standard formula for integration by parts. So let us consider an example problem. First one, find x into cos x, find integral x into cos x dx. So now here let f of x, which is equals to, f of x means it is the first function, g of x will be the second function, f of x equal to x and g of x, which is equals to cos x. So let us go for the integration. So integral x into cos x dx, which is equals to, so see the formula now, f of x, that means I have to write x as it is, then integration of second function, integral of cos x dx, and I have to write minus, then integral, then f dash of x, derivative of the first function, this is our f of x, take the derivative of this, what is the derivative of x, it is 1, so I write 1 here, then into integration of the second function, into integral the second function, that is cos x dx, close the bracket, write main dx. So this is the first step. So let us go ahead with this now. X I write it as it is. What is the integration of cos? It is sin x, then minus integral, this main integral I am writing it as it is. Then what is the integration of cos x? It is sin x. That means we get 1 into sin x, that is sin x. This dx I write it as it is. I hope you are understanding all these steps. Then x sin x. What is the integration of sin x? It is minus cos x. Minus into minus will be plus. cos x plus C. So this is the answer for the first example problem. So here the question that arises is, can we take the second function as first function and the first function as the second function? For example, if we take f of x as cos x and g of x as x. So what happens if we take these two? So let us take up this case also. So apply the formula here. So here let f of x which is equals to I take cos x now, we'll check what happens. Cos x and g of x which is equals to x. So let us apply the formula. So integral x cos x dx which is equals to, so f of x, it is cos x, into integration of g of x, that is integral of the second function, it is integral x dx minus integral f dash of x, derivative of the first function. What is the derivative of cos x? It is minus sin x, and then integral x dx, and then close the bracket, write one more dx. So now in the next step, cos x, integration of x will be x square by 2, then minus into minus it is plus, this main integral sign I write it as it is, then it is sin x into integration of x will be x square by 2 dx. So what did you observe from this? So in the previous case, if we take x as first function and cos x as second function, within 2 steps we have got the answer. So here if we take cos x as the first function and x as the second function, the given integral has been reduced to a more complicated form. So for this reason we follow the isolate rule for selecting the functions. See here, we'll rub this off. So here we have the formula, that is isolate. So we have, whenever you are integrating by parts, you have to follow isolate rule. So here I is nothing but inverse trigonometric functions, where I is going to be inverse trigonometric functions, and then L means logarithmic function, then A means algebraic function, and then T means trigonometric function, it is trigonometric function, and then E means exponential function, So this is the rule for integrating by parts. Whenever the function product of two functions is given, so check out this, whether it is inverse trigonometric or logarithmic or algebraic or trigonometric or exponential. Based on this, we follow the first function, taking the first function. You have to go from the left. For example, if the integral is this one, x into sine inverse x into sine inverse x, in that case, see the x, it is algebraic function, whereas sine inverse x is inverse trigonometric function. In this case, we have to take sine inverse x as the first function and x as the second function. For example, if you have this one, x cube into log x dx. So which one is going to be f of x and which one is going to be g of x? See the rule now. Dilate. After inverse trigonometry, we have the logarithmic function. That means log x is going to be the first function and x cube, it is algebraic. You have to take this as the second function. So this is the introduction of integration by parts. Well, before going to the second example problem, we have an important note here. See here. So the integration by parts method is not applicable in all product of two functions. For example, if you take integral root x into sin x dx. So here by parts method is not applicable for this particular case because the reason is there does not exist any function whose derivative is this one. We do not have any function such that whose derivative is root x into sin x. So you have to keep this in mind. It is not applicable in all the cases. So let us go for the second example problem. It is find integral log x dx. So now let us go for the solution. So here I, which is equals to integral, this can be written as log x into 1 dx, and we have to follow dilate rule. That means L, after I it is L, that means logarithmic function. We have to take log x as the first function and 1 as the second function. Let f of x, which is equals to log x, and g of x, which is equals to 1. It is 1. So now apply this particular formula. Integral of log x dx, which is equals to f of x. It is log x. It is log x. Then integration of the second function, that is the integral of 1 dx. Then minus integral, we have to consider a square bracket. F dash of x, derivative of the first function, it is 1 by x. Then integral of the second function, close the bracket and write one more dx at the end. So now, which is equals to log x into integration of 1 dx, that is integration of dx, it is x minus integral, we have to write 1 by x as it is, then integration of 1 dx, it is x. So I write the main dx at the end as it is. So now, which is equals to integration of log x into 1 dx, which is equals to which is equals to x log x. I write x in the beginning. So here x and x get cancels. So x log x log x minus integration of dx. It is x log x minus x plus c. So this is the required answer for the second example problem. And then we'll move on to the third example. Well, the question is x into e raised to x. The third example problem, find integral x into e power x dx. X into e power x dx. So here let us follow the ILATE rule. So A means algebraic. So here x is going to be algebraic function and e raised to x is a exponential function. So for that reason we have to take x as first function. Let f of x which is equals to x and g of x which is equals to e raised to x. Actually you have to write the formula every time. So here let us consider this integral x into e power x dx which is equals to, so f of x, that is x, into integral of the second function, it is e power x dx minus integral, so consider the square bracket here, then derivative of the first function, it is 1. So I write 1 here into integral second function, it is e power x dx, close the bracket and write one more main dx at the end. So now which is equals to, what is the integral of e raised to x? It is e power x itself, x into e power x minus, so here integration of e raised to x dx is e raised to x. So here we have 1 into e raised to x, it is e power x itself. I am writing this main dx at the end as it is. So now which is equals to x into e power x minus integration of e raised to x with respect to x will be e power x itself plus c. So this is the answer for the third example problem.